So looking at matrices on the calculator. So first of all, the determinant. These first two we're going to actually do by hand because it's faster. So the determinant is the difference between your diagonals. So here, that's what a diagonal is, right? So you multiply diagonally, 5 times 9, and we subtract the other diagonal. So the other direction, we're going to go this direction. We subtract 8 times -4. So you'd have 45. A negative times a negative is a positive 32, and our determinant would be 77. Okay, so on number 2, if we do that, you do your diagonals. So we would do 0 times -11 minus 4 times 6. Well, anything times 0 is just 0. So we have 0 minus 24. Yes? What is 0 minus 24? -24. Yeah? Questions? Now, to do that, these were 2 by 2s. Remember our dimensions of matrices, right? So that's a 2 by 2. This one is a 3 by 3. The determinant in this one is not just one diagonal, but you'd have to do 3 diagonals, which means you would have to write this matrix again and find 3 diagonals, multiply them and add them, and then find 3 diagonals, multiply them and subtract them. Okay? So it gets a little complicated if it's not a 2 by 2. So instead of doing that by hand, that's when our graphing calculator is going to come in handy. Okay? So it tells us up here, I kind of wrote you a few little notes to help you remember how to get those where they need to go. So to enter a matrix or a matrice into the graphing calculator, it tells us to do second, then matrix. So second is right there, and if you look, matrix is right below that math button. You see x to the -1? That's the matrix. Now, we're trying to store a matrice in there. So to do that, we have to go over to edit, and then you're going to pick where you're going to store it. I'm going to store it in A. So I would either hit 1 or enter. Now, we have what kind of a matrice? A 3 by 3. So I put 3 by 3 in, and then you literally just enter your numbers, making sure you use a negative and not a minus for the -8. So you're going to enter all of those numbers in. So you want this matrix to look just like this one. And real quickly, you'll notice that this is how we're used to writing matrices, right? With those square brackets, yes? Here it looks like absolute value signs, doesn't it? We write them this way, but you also need to recognize that some books, some tests will have them written like this. It means the same thing. All right, so your absolute value bars is what it kind of reminds me of. That's still a matrice. Okay. Does everybody have their matrix stored? Any questions on how to store a matrix? Make sure if you have a question, you ask it, because if you don't know how to do that piece, the rest of it's going to not be easy, right? Everybody good? Okay. So we've stored it. Now we need to do something with it, right? So we need to get back to that blank home screen. So to do that, we do second mode or second quit. So the second button, and right beside it is mode. And then to find a determinant. So to store a matrix, we're going to use this a lot. We're now going to find a determinant. So to do that, we do second matrix again. This time we're trying to find something. We're trying to do something with the matrix. So we're going to go over to the math feature, and this is where we would find all of our different things that we can do with it. So right now we're going to find the determinant, DET. It's abbreviated there for us. So we're going to select 1. We want the determinant of which matrix? Where did you store that one? I stored it in A. Is that where you stored it? So I want matrix A there. So to do that, I would do second matrix again. And this time I'm going to select matrix A under the names. I'm just going to hit 1 or enter. And if I hit enter, it gives me the determinant. So the determinant of this is negative 93. Okay? Now, looking at the next piece, it says operations with matrices on a calculator. You did this by hand while I was gone, right? We added them, we subtracted them, we multiplied them. Yes? We're going to do this on the calculator. So you know how to do this by hand. You would multiply 3 times all of these elements. Yes? And we'd multiply 2 times all of these elements, correct? And then we would add our corresponding elements together. Do you agree? Well, to do this on the calculator, we're going to want to store all 3 of these matrices. How do we store a matrice? What do we do? Second matrix, and we're wanting to store it, so we have to edit them, right? And we want to store it in A, in B, and in C. So in A, what is the dimensions of this A? 2 by 2. And then we enter our numbers, right? Negative 3.2, 1.7, 0.4, hitting enter after each one, right? So once that one's stored in A, I now need to store something different in B, don't I? Yeah? So if I go second matrix again, I need to go down to B, hit enter. Oh, nope, sorry, I got to go over to edit first, then down to B, and we want to edit that one, right? So anytime you want to edit one or store one, you have to go to edit, yes? So then in B, what do I have here? It's a 2 by 2, isn't it? Yes? And then I need to enter these numbers. Some of you might already have this one in there if you're using some of these calculators up here, because First Hour did it for you. So you store B in there. And then what do I need to do? Everybody have A and B? Yes? No? Yeah? How do I store C? What do I do? Walk me through it. Second matrix. Go to edit. Go down here to the 3, correct? And this is a 2 by 3. And you need to make sure that you have all of these stored exactly like they are, yes? So if you're using your own calculator, you definitely need to put all of those in. If you're using one of mine, that might already be there for you, right? Everybody good? So we have all of these stored, yes? Now I want to do some operations with them, correct? So I need to get back to a blank screen, and I do second quit to get back to that blank screen, right? And you can always hit clear to get back to nothing on there, yeah? Now, I want to do 3 times matrix A plus 2 times matrix B, yes? So in parentheses, I'm going to do 3 times. How do I select matrix A? Second matrix and select 1, right? And I close my parentheses. And then I'm going to add, again in parentheses, 2 times, how do I select matrix B? Second matrix, and I want to do number 2 this time, right? Close that parentheses. Yes? Hit enter, and it gives me that value, 0.2, 5.7, negative 13, negative 12.2. Make sure you write it as a matrix which has the brackets around it, yes? Now, much faster, especially if you're going to do multiple things with the same matrices, yes? All right, let's look at number 2. What do we do on number 2? First of all, if you were to multiply these by hand, what do we have to know? Remember, that's where you multiplied the whole row times the whole column? Yeah? That was a lot of work, right? Multiplied the whole row times the whole column on each element, yeah? So remember with A, this is a 2 by 2. Do you agree? What is C? Do you remember that these two had to match? They had to agree? And then it became what the outside one was, right? So when I multiply these, you're going to get a 2 by 3. Do you agree with that? 2 rows, 3 columns? Yeah? So let's multiply these. We would do second matrix. We're going to select matrix A times second matrix, and I'm going to select matrix C. And if you look right there, you get negative 31.86, 32.44, negative 6.38, 49.8, negative 46.52, negative 0.32. Yeah? Is that much faster? Yeah. All right, let's look at number 3. Here we do 2 times in parentheses, and I do second matrix, and I have to select C first, times second matrix, and then I have to select B. Remember, multiplying matrices isn't like multiplying numbers, right? If we multiply numbers, you can multiply 2 times 3 or 3 times 2, yes? Multiplying matrices, we can't do C times B is equal to B times C, right? We saw that on our homework, yes? What happens? What does it tell us? It says check size DIM, which, what do you think that means? Dimensions of lists or matrices. Well, what is the dimensions of C? And what's the dimensions of B? Do those agree? So my answer, what do you think my answer is supposed to be? Impossible. You cannot say no solution, right? We're not trying to find a solution, are we? We're not trying to find a set, so we can't use the empty set, the circle with a line through it. We're trying to know whether it's possible or not. This one was impossible. Yes? Okay. Now on the back, this was also in Unit 3, right? Systems of equations. Do you remember you solved systems of equations by graphing them? Then we used substitution, correct? And the last one we did was elimination, yes? Well, here's a fourth way, which is to use matrices. And if you use matrices, you can plug it into your calculator. So we're going to use what's called augmented matrices to solve systems of equations. To do that, we use what's called reduced row echelon form. Now, you can do this by hand, and you're doing multiple matrices to get to the reduced row echelon form, which is abbreviated RREF. That's important. Not just REF, but RREF, okay? You need to know that. That's what you're using, because on your calculator, you're going to have to select the RREF, okay? Now, back to our 3 different types of answers. Remember, one way was if your lines crossed, you had an XY point. Do you remember that? It's the point where it crossed, yes? It was like a point -1,5 or 2,3 or 5,4 or whatever, right? Wherever it crossed. What happened when you had parallel lines? What was your solution? Do they ever cross or touch? So this was no solution, right? And then what happened when we had one line directly on top of the other line? Remember, every one of these points is a solution, right? How did we describe that? Infinite solutions. So there's three possibilities. You're going to either have an XY point, you're going to have no solution, or you're going to have infinite solutions. That was the same when we were graphing them using substitution and elimination. It's going to be the same when we're using augmented matrices. Okay? So let's look at example 1. Before we can write them as a matrix, we have to make sure they're in the right form. So we want the constant on the right-hand side of an equal sign, and we want x plus y. Well, those are already in x plus y equals a constant, yes? So now we can write a matrix. And what we're going to look for here is the coefficients. So the number in front of the variable. The number in front of a negative x is considered to be -1, yes? Here you would have 1. And then because we need an equal sign, what we use there is a colon there, and it equals 3. That's just showing the augmented matrices. That's what that looks like. All right, so then this row would be what? -2, 1, and 6. This first column represented our x's. Do you agree with that? The second column represented our y's. And the third column was the constant. Do you agree? How could we store that matrix? What do you do? How do I store it? Second matrix. Over to edit. I'm going to put it in A. You could put it in whichever one you want. What are the dimensions of this? 2 by 3. And we enter our numbers. -1, 1, 3. -2, 1, 6. Now it's stored there, right? I've got to get out of that window. And now I want to find something, yes? I want to find that reduced row echelon form. So I do second matrix again, and where do I go to find something? Math. And then you're looking for the RREF. If you scroll up, it's going to be closer. You could obviously scroll down too, but if I scroll up, I'm looking for RREF. You can see it there, yes? I hit enter. What am I trying to find the reduced row echelon form of? Matrix A, wherever I stored it, right? And I hit enter, and it gives me a new matrix in reduced row echelon form. This would be 1, 0, -3, 0, 1, 0. Well, what this means is that we have in this row, this was our x, right? So we would have 1x, this was an equal sign, equals -3. And in this row, what are you left with? 1y equals 0. Do you agree with that? So that means our solution is an xy point, -3, 0. And that's your solution. Now what that means is these two lines crossed at that point, yes? If you were to have graphed those two lines, they would have crossed at the point -3, 0. Questions there? All right, looking at number 2, what's wrong with number 2? Okay, so I'm going to rewrite it. I'm going to switch my order here. I want -x plus y equals 6. And -3x plus 3y equals 10. And then I write it as a matrix. Here it would be what? -1, 1, 6, and then okay, what do I do? I need to store that, don't I? You could store it wherever you want to store it. I'm going to store it in B. Just because. Oops. Got to go over to edit. I'm going to store it in B, and I need a 2 by 3. And I plug in -1, 1, 6, -3, 3, and 10. Now what do? I quit it because I went back to my home screen, right? And now I'm trying to find a value, aren't I? So to find the value, I do second matrix. I want to find something, so I want to use the math feature. And specifically, I'm trying to find the reduced row echelon form, yes? RREF. And I'm trying to find that of wherever I stored my matrix, right? Do you agree? So I'm going to do second matrix. I stored mine in B. And I hit enter. Now, this gives us 1, -1, 0, 0, 0, 1. Well, I don't have like 1x equals something. I would have x minus y equals 0. And here I would have 0x, 0y equals 1. Do you agree with that? The problem is this right here. Can a 0x and a 0y equal 1? No, 0 and 0 is 0, right? So is this a true or false statement? So anytime you see this, this does not work. And so if it doesn't work, your answer is going to be, which of those three do you think it'll be? There is no solution. What that means is if I were to graph these lines, they would have been parallel lines. They would have had the same slope but different y-intercepts. All right, 3. They're in the right form, aren't they? So I would have 1, 1, and 2. 2, 2, and 4. Everybody agree with that? What do? Second matrix. And I want to store it somewhere, right? So I go over to edit to store it. I'm going to store it in 3. This is a 2 by 3. Everybody agree? All right, I've got it stored. Now what do? Quit. And then second matrix, math. Yep, RREF. And then select my matrix, right? My matrix was in, I stored it in C. And it gives me a new matrix. And the new one is 1, 1, 2, 0, 0, 0. Well, 1x plus 1y equals 2, and this would be 0x, 0y equals 0. Is that possible? Is it possible to have 0 plus 0 equals 0? Yes, this right here tells us yes, it's possible. And so if that is possible, then what do you think would have happened? Yes. It's going to be infinite solutions because essentially that is the same line, which you can see if we divided that bottom equation by 2 all the way across, we would get the same thing as the top equation, right? Means they're the exact same thing. So they would be graphed directly on top of each other. Questions on that? Okay, on number 4, we did not do this, but you can use elimination and some substitution to solve. If you have 3 equations or 3 variables, you'd have to have 3 equations. If you had 4 variables, you'd have to have 4 equations. It's a whole lot of work when you do it by hand, but you can do it. We are going to use the calculator to do it for the sake of time. So you use the same process. Here we have x, y, z. We want to make sure they're all in the same form. We want it equal to a constant, right? If one of the equations, say, didn't have a z in it, you would have to plug in 0z for the missing value because you have to have the same number of elements in each row. Does that make sense to you? Yes? All right, so let's write our augmented matrix here. What would it be? First row is going to be 2, 1, 1, and 1. Second row is going to be 3, 3, and 12, correct? And the bottom row, 4, 1, 2, and yes. And now I need to enter this again, don't I? How do I enter it in my calculator? Second matrix, and I'm trying to edit it, right? I'm going to put it in the first one. How many rows and how many columns? 3 by 4? And we just enter everything in. Once I have it stored, what do I do? And then what? Yep, RREF. And then I have to select the matrix where I stored it, right? So I stored mine in A. And so you can see this equals 1, 0, 0, negative 4, 0, 1, 0, 3, 0, 0, 1, 6. So you can tell you're going to have a point if you have a 1 in each column and zeros and everything else, right? So like here, you can see it's 1x equals negative 4. This one would be 1y equals 3, right? And this one would be 1z equals 6. Do you agree with that? So this becomes an x, y, z point. So x is negative 4, y is 3, z is 6. If you were to try to graph this, it can be done, but it's 3-dimensional, right? 3 variables means it's going to be 3-dimensional, 3 axes. Okay? We aren't going to do that because 3rd dimension stuff to graph on paper is not exactly easy. Okay? Questions? Pretty simple. Much easier with a graphing calculator. Yeah? Okay.